In the given system of equations, k is a constant. The system has exactly one distinct real solution. What is the value of k? So we have these two equations here, and we're told that the system has exactly one distinct real solution. So that means there's only one value of x and y that satisfies these two equations simultaneously, meaning they intersect at only one single point. And we need to find a value of k such that this condition is true, that there is only one distinct real solution. So from the quadratic formula, we remember that x equals negative b plus minus square root of b squared minus 4ac all over 2a. And these a, b, and c coefficients are used from the standard form of the equation, which is ax squared plus bx plus c equals 0. So we know that in here, this term that's inside of the square root is known as the discriminant. And the discriminant tells us how many solutions there are. So if there is one real solution, the discriminant, b squared minus 4ac, is equal to 0. If there are two real solutions, b squared minus 4ac is greater than 0. And if there is no solutions, meaning no real solutions, the solutions are imaginary, then b squared minus 4ac is less than 0. So in this case, we want the case where there is one distinct real solution. And that's when the discriminant is equal to 1. So what we're going to do is combine these two equations by subtracting this one from the first one so that we get one equation, and then rearrange it to look like the standard form of a quadratic, and then find the discriminant and solve for the value of k. Okay, so let's first subtract one equation from the other. So we'll do this equation minus this equation. So we'll have y minus y, which is just 0, k minus negative k, so that's just 2k, since negative k times a negative is positive. Then on the right side, we'll have x plus 26 minus x squared minus negative 5x. So that's just plus 5x. Now let's move everything to one side. We know that this here is actually just a constant, like 26 is a constant, because we're told that k is a constant. So this k is just some number. It could be like 3 or something. So this term is really just a constant. So let's move this to the other side. So we'll have 0 equals negative x squared plus, let's combine x with 5x to get 6x. And then we have the constant. So we have 26 is one constant and 2k is one constant. So when we subtract it from both sides, it'll actually be a negative on the right hand side. So we'll have negative 2k. Okay, so this is our standard form of a quadratic, where this is our a term. So our a is negative 1. The coefficient of x is our b term. So b equals 6. That's this term here. And then we have our constant. So this whole thing is our constant. Our constant is 26 minus 2k. So then we have our values of a, b, and c. So now let's write the discriminant. So the discriminant is b squared. So that means 6 squared. So 6 squared minus 4 times a. A is negative 1 times c. And c is 26 minus 2k. And we want that to equal 0 because we want the value of k such that the discriminant equals 0. Because at that value of k, there's only one real solution to the quadratic. Okay, so now let's simplify. So 6 squared is 36. Negative 4 times negative 1, that's just, we can just rewrite this as 4, positive 4, and then multiply this 4 with both of the terms in this parentheses. So if we get out our calculator, So we have 4 times 26. That's 104. And then 4 times 2, well, negative 2, that's negative 8, and then the k. So then we have this equation here. Now let's just combine these two like terms. So 104 plus 36, that's equal to 140 minus 8k equals 0. So then we can move the 140 to the other side to get negative 140. So then we have negative 8k equals negative 140. And if we divide both sides by negative 8, we just divide by negative 8 on both sides. So we'll have k, since the negative 8 and the negative 8 cancel out. So we'll have k equals negative 140 over negative 1/8. So negative 140 divided by 8 is equal to 17.5. The negatives, they cancel out. So that means when k equals 17.5, the system of equation only has one real solution.